Hello, welcome to Notes 1.4, where we're going to talk about measures of spread. We're going to talk about outliers to finish up our CSCSO from last video, and then talk about a new quantitative display called the box plot. Let's get right into it because there's a lot here. So spread, that's us trying to sort of describe how spread out our data is, how sort of clustered up is it compared to the center? How much is our data clustered around the center or not so clustered around the center? And there's three different ways to sort of talk about that. Let's get into the first one, standard deviation. Standard deviation is the average distance a value is from the mean. Okay, and just like with mean, notice that it uses mean there. These get paired together, standard deviation and mean. So if you're talking about a sample, okay, remember with mean, there was different notation for sample versus population. Same thing with standard deviation. If you're dealing with a sample, then we go with S. Just the plain old S, okay? Sometimes there's some subscripts on it if we're dealing with multiple things. But if you're dealing with the population, we use the ancient Greek letter that is the S, which is the sigma, which sort of looks like this. I'm not very good at drawing it, but I think I'm doing a pretty okay job there. So yeah, if you're like, what was that? I don't know if I draw it correctly. I'm not sure if it's, the hand movement I did is the correct one, but that's how I usually do it. It kind of looks like an O with a fun, hair bang sort of situation going on. But it is not an O, it's actually a lowercase s. So there you go, standard deviation. Now, it has a formula associated with it. Let me show you over here on the AP formula statistics sheet. So if you could pull yours out. So we talked about sample mean last time, and there's also sample standard deviation right here. And fun fact, you don't need to actually know how to calculate this by hand. Your calculator can actually do it for you, and that's the beauty of it. But they'd still give you the formula right here. So if for some reason, I don't know, you forget your graphing calculator at home and you need to find the standard deviation of something, then you can easily go and crunch it out. But that's not usually the case. But there's the formula. You can sort of see how it works out. It squares in order to make things positive, but then takes the square root later on, so it sort of undoes it. But there it is. And you might be wondering, well, where is population standard deviation? And just like with the population mean, it shows up here, as you can see, in these different probability distributions. And I think if we continue onward, and then here we see some more sample standard deviations dealing with proportions, things we'll get to later on. Here's the population standard deviation for those things as well. Those are all things that we'll talk about later this semester or next semester. For the purposes of what we're dealing with today, this formula right here is literally the only one you need to sort of worry about, and not even really, because your calculator can do it. In fact, let's go ahead and do that right now. So we're going to go ahead and take a look at how we can calculate standard deviation on the calculator, okay? We're not going to bother with that formula. Instead, what we can do is we're going to first ensure that we have our data in a list. Here in list 1, this is all of the caffeine data from, I believe, notes 1.2. So if you wanted to go back and take a look at that, you can, or just sort of watch what I do here. But once you have all of your data in a list, you're going to go to Stat. That was this button right here, Stat. And you're going to click over to Calc. And you can see right there, that very first one var stats. I'm just going to press 1 or press Enter. It's going to ask for what list you want it to be. I'm going to go ahead and change it to list 1. So I hit second, and then the 1 button makes it a list 1. And then I go ahead, frequency list, I don't need that right now, and I'm just going to go down and hit calculate. And so you can see there that it calculates for us the mean, x bar, okay? And then here, SX, that's what we want. That's the standard deviation of a sample. It also gives the sigma. If this was a population, it's a slightly different calculation, but it says in our original data there, this was a sample of caffeine in different drinks. So we would go with the 7.128. So in other words, on average, the amount of caffeine deviates from the mean by about 7 milligrams. All right, let's keep going on here. So the other ways to measure spread is interquartile range is another one. So interquartile range is basically talking about like how spread out is the middle 50% of your data. So you try to find the 25th percentile and the 75th percentile, and you take the difference of those two things. So the formula is just right here. So that is the interquartile range, okay? Sometimes people give it as like, you know, oh, the interquartile range is from here to there. That's technically wrong. It should just be the distance. So just that one single value. I'll show you an example of that down below. The third way, though, is to talk about the range. That one's a pretty common one that you might be familiar with. Range is just the distance from the minimum to the maximum. Again, you don't want to actually say from 20 to 70. That's technically wrong. You would say 50. The range is 50 because the distance from 20 to 70 is just 50. And you might also be wondering, well, when do you know when to use which of those three things? We'll get to that later. I want to move on to outliers. So outliers, as you probably already knew, is just that like you got some data values or maybe just one that seems to fall outside the overall pattern of the rest of your data. And so sometimes it's just you're eyeballing it. Like if you're looking at a histogram, you might just go like, and it appears that there's an outlier at blah. But it turns out there's actually a hard and fast rule if you have specific values from your data. So we just talked about the IQR, interquartile range. That's something you could use to help you figure out whether you're dealing with an outlier. If you find 1.5 times your IQR, so you find your IQR and you multiply it by 1.5. If your data falls either 1.5 IQR below the first quartile or 1.5 IQRs above the third quartile, then those would be marked as outliers. Those are things you would call an outlier. And again, we'll do the calculation for that in just a moment here. But that's the hard and fast rule. Your calculator can actually kind of figure this out for you, and I'll show you that too. But it is sort of nice to know what it is based off of just the actual formula, because sometimes the questions might be asked that are easier just to do this calculation really quickly than it is to go into your calculator. So all of this brings me to our last quantitative display, which is called the box plot. So the box plot displays the 5-number summary. The 5-number summary is the minimum, first quartile, median, third quartile, maximum. And it does it all in sort of like a box and whiskers, and sometimes outliers get sort of marked differently. So to do this, it's great to find your 5-number summaries first, okay? That's what we'll use the calculator for here in a moment. It's also important to label and scale your axes. So I have some data here, and it doesn't have any context because I was running out of space. So let me tell you what the context is. Those 20 data values you see in those boxes right there, that is the number of wins the Warriors, the Golden State Warriors, have won in a season dating all the way back to 1995 up to 2015, okay? So as you can see, there are some seasons that didn't go so well, okay? And then there's some seasons where things went a little bit better. There's particularly one season where they did really well. And so that's the data we're going to use here today. And we're going to do that to help us label. We're going to go ahead and say that our axes for our data here is going to be the number of Warriors wins, or just Warriors wins in a season. And let's go ahead and scale as well. You can wait until later when you pull up your calculator to see maybe what a good scale is, or you can kind of just go into it and jump in and sort of mark it out so that way it works for you. I happen to know that this works out really well if we start at 15 and then go by 6s. So I'm going to go ahead and do that. But if you were wondering like, well, how did you know that? It's because I've done this problem before. But you can always sort of tinker around, or like I said, go to your calculator and actually do it and see what your calculator scales all of the data as, and you can just use that as well. All right, so there we go. Why don't we go ahead now and at this point, jump to our calculator and see what our 5-number summary is and see how to make a box plot on our calculator as well. So now let's go ahead and see how we can find our 5-number summary and our box plot on the calculator here. So what we're going to do first is go to our lists, so stats, and then that first one, edit. And I put all of the Warriors wins data in my list 2 right here, of which I just realized one of them is wrong. So it's a good thing I came through. That should be a 19 right there. So go ahead and enter all of your data there. It should be 20 in total. Pause if you need to. And then for the 5-number summary, it's actually a very familiar thing. We can hit Stat and move over to the Calc menu. And that 1var stats right there, that is exactly the same thing. The same thing that gave us the mean and standard deviation of the caffeine data, we can go ahead and do here. So I'm going to go down. I have all my stuff in list 2 for me, so I'm going to go ahead and change that by hitting second and the number 2. And then I'm going to arrow down to calculate. And so I have here my mean and my standard deviation, but what I'm more interested in is the 5-number summary right here. So I got min at 17, first quartile 22, median 34, third quartile 42.5, maximum 83, which we noticed that 83 was the largest. So go ahead and write that down. Pause if you need to. And then this thing can make a box plot for us based off of that data. So what we're going to do is we're going to hit second and then the y equals button here, but since we hit second, it'll take us to our stat plots. So the same place where we made like histograms and stuff like that are in here. So we'll just go to that very first one. It's turned on. If yours is turned off, you can always arrow over and press enter on. The type, we're going to go with this 4th option here, which is box plot, and then you can see there's some dots next to it, as opposed to this one, it's all connected. The reason we're going to do this one is because it's going to show us outliers. This one will not show us the outliers, and we want to see where there's outliers. So we're going to go and hit enter on that. It's going to ask us what list we want to use this from. I put all of my Warriors win data in list 2, so second and 2. Frequency. Mark, these are to show outliers. So when they show outliers, it'll come up as whatever you decide you want to call it here. I like to stick with the first 2. Really, I just stick with the first one, the box or the plus. The other ones, especially that last one, is so tiny that your eyeballs actually might miss it. And then if you want to change a color, you can if you have the color option. And then we're going to hit zoom and 9. That zoom stat is what we want. You can arrow down or just hit the number 9, and then it shows it for you right here. So there is our box plot, okay? If you're interested, if you were like, I don't know what to scale by, you can go in and hit window, and it kind of lets you know that's the smallest X value it's showing is a 10.4. The highest one is an 89. So if you wanted to try to, count it out and go by whatever you need to, starting at 10 and getting up to 90, that would work out really well. They go by 6s, but I don't think we had enough notches to make that work for us. Going back to the graph here, so you can hit the trace button and it'll also tell you the different values here. So median 34, but if I arrow left, first quartile 22, minimum 17, third quartile 42.5. This is just a value. It's the second highest value, the 54. So the whisker only goes out to 54, not all the way to the maximum, because 83 is in fact an outlier, which we will calculate here in just a moment. You don't have to draw this because we'll do that together by hand in just a moment. All right, so you got to see how that works out, but I wanted to sort of do some things by hand back over here too. So I wrote down the 5-number summary, and what I wanted to do was show you how the sort of calculations for IQR and calculations for figuring out if you have any outliers work. So let's do that. So IQR is the first thing we're going to do. And remember, IQR is to simply find the distance between the first quartile and the third quartile here. So we'll do that. We're going to go 42.5 minus 22, which gets us 20.5. So that is the IQR. The middle 20 or middle 50% of Warriors wins are separated by 20.5 wins. Now, to use this outlier rule, what we actually want to calculate is 1.5 times the IQR. So 1.5 times 20.5, that's going to get us 30.75. So that's the distance that we're going to sort of use moving away from the first quartile or third quartile to figure out, do we have any data values that fall beyond sort of those cutoffs? So let's check the lower bound first. So we're going to go quartile 1, which is 22, and we're going to take away the 1.5 times the IQR, which was 30.75, which gets us negative 8.75. Do I have any data values that fall below negative 8.75? No, it's not possible. We're talking about number of wins. You can't get negative wins in an NBA season. So because of that, we don't have any lower. But if this was a scenario where maybe negatives are possible, then anything that would fall below a negative 8.75, we would mark as an outlier. So if we had a negative 12 somewhere in our data, we would mark that as an outlier. Let's check the upper bounds now, though. So we're going to go 42.5 and add on the 1.5 times the IQR, which is going to get us 73.25. Do we have any data values that fall above that? Well, yeah, we have 83. 83 is something we're going to mark as an outlier, which we saw on the calculator was already marked for us. And we saw that when we go to draw our box plots, when we go out for the whisker on the right side, what we're going to do is we're going to use the second largest value to sort of stop that whisker and mark the 83 as a separate point entirely. So that's how you do that by hand. Now let's go ahead and do our box plot by hand as well. There are many ways to sort of do it. Let me show you how I like to do it. I like to start with sort of the box parts and not worry about the whiskers yet. So I come in and I go, okay, I have a quartile at 22, third quartile's over at 42.5, and the median's at 34, like so, and I just make my box. So there you go. There's my sort of middle 50%. You can see that the IQR is sort of being represented. How long that box is your IQR. And then I'm going to go ahead and mark out the minimum at 17 and draw a little whisker. And I'm not going to go to the maximum because the maximum is the one I need to mark as an outlier. So instead, I'm going to go to the second largest, which is the 54. So at 54, I'll also draw a little whisker out to there. And the 83 is what I'm going to mark as an outlier. There's different ways to do it, as you saw on the calculator, but I like to use a little asterisk to sort of show that. So there you have it. And then one last thing you can do that I think is really helpful is to label each of the sort of important points along the way. Even though I have the 5-number summary right above it, sometimes it's not there. And it's nice to just sort of come in and label like the minimum 17, the quartile in the front there's 22, 34, 42.5, this is 54, and then this is 83. So that's how you make a box plot by hand. Let's go ahead now and move along to the backside, which has us thinking about, well, if there are these 3 different ways of thinking about spread, how do you know which one to use? And you know what? It falls in pretty closely to how you would use the same conversation around measures of center. How do you know when to use mean or median? So in this particular case, standard deviation is best when the distribution is approximately symmetric or, no, that's all I want to put, sorry. The next bullet point, the distribution is multimodal with no outliers. So there you go. And symmetric, I should also say no outliers as well. So it's really the same thing we thought about when it came to using mean. Mean really made sense when things are symmetric or there aren't heavy outliers. So that's good to sort of have in your back pocket there. How about interquartile range? When is that best to use? Well, that one's going to be good when you have a distribution that is skewed left or right. So not symmetric, it's very skewed. And another one is if it has outliers. So in the above example where we talked about the Warriors and their number of wins, I'd probably use interquartile range to talk about sort of how spread out the data is, because that outlier of 83 is really going to mess with that standard deviation and bloat it up too much to be a number that really means much to us. The last one is range. The range is rarely used, but it is used in one particular time that is helpful, which is your display is a histogram. If you have a histogram, you only have those bins, and the bins don't tell you exactly where the minimums and maximums are, so you'd only be looking at it and going like, it has a range of about this, because you're just sort of using the bin as an idea for how spread out it is. But if you have exact data values, if you have a box plot, if you have a stem and leaf plot, if you have a dot plot, those, because you can get more accurate with it, range is not the best to use. All right, so to finish up, we're going to go ahead and let you do these last two examples. What we'd like you to do on your own here is to describe using context, shape, center, spread, and outliers each distribution here, okay? And then when we come into class, we'll have you share with each other and talk about what did you choose? Did you choose mean and standard deviation, or did you choose, interquartile range and median, or did you choose range, or did you choose something completely different? Did you call that an outlier or not? Why or why not? So go ahead and calculate these things out, write it all out, beautiful sentences, and come in to discuss.